Hello, welcome to the CCNA study guide brought to you by Eduonix. This is the sixth and final video of chapter 1, and we're going to be identifying the appropriate media, cables, ports and connectors to connect Cisco network devices to other network devices and hosts in a particular LAN. So Ethernet standards here. So defined by the Institute of Electrical and Electronic Engineers, the standard defines cabling, connectors, on the ends of the cables, data link protocols, that rules and controls, and the pieces that are required to create the Ethernet frame. So plugging Ethernet standards together will get you a local area network or a LAN. That is a combination of user devices, switches, and any kind of cabling that you can possibly think of. Ethernet has consistent properties of all types of media using Ethernet. In the data link layer, no matter whether the data flows over UTP copper cable, fiber optic strands, or over radio wave, and no matter what speed it is, Ethernet data link headers and trailers use the same format. So logically speaking, Ethernet data link layer 2 protocols focus on how to send an Ethernet frame from hop to hop using a source and destination MAC address. Physically speaking, layer 1 standards focus on how to convert bits to bits on the cable. So here we have the speed of 10 meg, 100 meg, 1000, and 10 gig. And you can see the max cable length down the right hand side here, such as copper 100 meters, fiber 5000 meters, copper 100, and the actual formal name of 802.3, 802.3U, Z, AB, and AN. This is generally what you have to look at. You have the informal name here, and then in the exam you'll be asked for, so say what is 100 base T also known as. It's also known as 802.3U, and it has a maximum transmission speed of 100 megabits per second. That's generally the kind of thing that you need to know about. So the wires inside the unshielded twisted pair are twisted together in parallel. The twisting helps solve some of the important physical transmission issues. And when electrical current passes over any wire, it creates electromagnetic interference, or EMI, and that interferes with the electrical signals in nearby wires, including the wires in the same cable. So EMI between wire pairs in the same cable is called crosstalk. So twisting the wire pairs together at the factory helps cancel out most EMI surrounding the UTP cable when it runs beside electrical equipment, and cancel out crosstalk that comes from another neighbouring pair inside the UTP cable itself. Most networking physical links that use copper use unshielded twisted pair, or UTP. The 10 base T and 100 base T standards require only 2 pairs of wires for each connection in full duplex mode, while a 1000 base T standard requires 4 pairs, 2 for each direction, and the default is full duplex. Half duplex isn't an option with 1 gigabit Ethernet, it's generally only full duplex. So to understand the wiring of UTP cable pin positions on both ends of the cable, you need to first understand how the PC network interface cards, or NICs, and switches interfaces talk to them, and what's used for TX and what's used for RX. As a rule, Ethernet PC NIC transmitters uses a pair of connectors to pins 1 and 2 to listen or receive. The switch interface ports use a pair of wires at pin positions 3 and 6 to listen and receive. So consider a phone call. You picked up the phone and you start talking, your voice transmitter going through the microphone, and the person who's listening to your voice on the other end receiving your voice through the speaker. The same thing happens between the PC's NICs and the switch interface ports. PC NIC talks to the transmitter on TX, and then after that it talks on pins 1 and 2, therefore listens and receives on pins 3 and 6. Switch interface talks on pins 3 and 6 and listens on 1 and 2. So to allow a PC's NIC to communicate with a switch, UTP cable must use a straight through cable pinout. And the term pinout refers to the wiring of which colour wire is placed in each of the 8 numbered pin positions on the RJ45 connector. An Ethernet straight through cable connects the wires at pin 1 on one end to pin 1 on the other end, and pin 3 to pin 3, etc. So briefly, 1 and 2 pinouts connect straight to 1 and 2 pinouts, and 3 and 6 connectors straight through to 3 and 6. So the total will be 2 pairs on a straight through, and that's called a straight through cable. So just to kind of reiterate that. So the devices that generally transmit on pins 1 and 2 would be a PC NIC, a wireless access point, a router. What else transmits on there? Pretty much anything that would be cable like that. Your home router at home, anything really. And devices that transmit on pins 3 and 6 would be things like hubs and switches. So straight through or crossover cable. So if 1 and 2 type devices, such as a PC, connect to 3 and 6 devices, it requires a straight through cable. And if 1 and 2 connect to 1 and 2 device, it requires a crossover cable. So then you reverse it, and if a 3 and 6 device needs to connect to 1 and 2 device, it's still a straight through cable. And then if a 3 and 6 type device connect to a 3 and 6 type device, it requires a crossover cable. So when we talk about 1 and 2 type devices, we're talking about PCs, routers, and NICs and wireless access points. And when we're talking about 3 and 6 type devices, that is when we talk about hubs and switches.